All right, we are learning our very last section in chapter 3 now. It is 3.6, perpendiculars and distance. So the whole point of this section is trying to find like the distance between a line and a point that's not on the line, or how do you find the distance between two parallel lines? Those are the two specific things we're going to look at. So I have a question for you right here. It says, how do you find the distance between a line and a point that isn't on the line? So I've got a line drawn. Let's say that we have some point, doesn't matter where it is, just pick a point, but it's not on the line. How would you find the distance between those two things? Like, what does that even mean, the distance between them? Like, would that be like from here to here? Is that the distance between them? Or maybe like from the point to the end point over there? Is that the distance? Maybe over here? So you can see like there's lots of line segments you can draw. When we talk about the distance between two things, like between this line and this point, we are interested in finding the shortest distance, which would actually be the perpendicular line that exists between the two of them. So we've got this little key concept here. It says the distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. So that's what we're going to be looking at here. So just a basic little question right here. Read through this, pause it, see if you can answer it. I'll give you a second to do that. Okay, so it says, which segment represents the shortest distance from point A, right here, to DB? And the correct answer is D, AX. Very good. This would obviously be the shortest distance, which is the perpendicular distance to this line segment. All right, sounds pretty easy. These can get a little bit complicated when we're dealing with the coordinate plane. So I've got steps for you guys, so make sure you pay really good attention and you write down every step. Okay, all 4 steps. And then every practice problem you do after that, you can just follow those 4 steps that you write down in your notes. All right. So first thing we're going to look at is how to find the distance from a given point and the line. We want to find the distance between them. Okay, so here it says line S, that's what they're calling this line, contains points at 0, 0 and negative 5, 5. Find the distance between line S and point V, which is over here at 1, 5. All right, so we're going to break this down into steps. Our very first step is we want to find the slope and just write the equation of the line that they give us. Okay, we want to write the equation of that line, and we know how to do that. That's just basic algebra. So to write the equation, let's first find the slope. Looks like we got a point here. We go down 1 over 1, down 1 over 1. So slope of negative 1. Okay, and then we need our y-intercept to write the equation of the line. And of course, it is going through the point 0 right here. So I could say my b, my y-intercept, equals 0. So the equation of this line is y equals negative 1x, or negative x, plus 0. So we would just leave it as y equals negative x. All right, so we know the equation of that line. Let's go ahead and move on now. Okay, so right here, here's the equation of our line. Now, step 2, we want to write the equation of the line that goes through this point they gave us and it's perpendicular to this line, right? Because we want that perpendicular distance between them. So let's find the equation of the line that goes through this point and it's perpendicular to the line that we just found. All right, so we know that it goes through the point 1, 5. That's going to be helpful. Point 1, 5. And we also know its slope, because it is perpendicular to the line that we just found. So what's the slope of the line we just found? Well, it is negative 1. So the slope for this one is going to be the opposite reciprocal of negative 1, which would just be positive 1. So we know 2 pieces of information. We know a point on the line, and we know the slope of the line. So you could use point-slope form to write the equation, or most of you guys are a fan of slope-intercept form. Y equals mx plus b, and we can just use that also. Okay, So in for our x and our y, we can plug in our x and y value we have here. In for m, we can plug in 1, and then we'll be able to solve for b that way. So let's solve it this way. So instead of y, I'm going to put in my y value here, which is 5, equals m, which is 1, times x, which is also 1, plus b. Simplify that. 1 times 1 is 1. Subtract that from both sides. So we get b equals 4. Okay? So we've got our b. We know our m. We can go ahead and write the equation of this line. It would be y equals 1x plus 4. Okay, so that's step 1 and step 2. Step 1, we found the equation of this line they gave us. Step 2, we found the equation of the line that goes through this point, and it's perpendicular to this line. All right, let's move on. Now, step 3, we want to know where those two lines intersect. We can kind of probably eyeball it, like it looks like it's going to be over here, right? It won't always be that obvious though, so you need to be able to do the algebra behind it. In order to figure out how two lines intersect, you have to solve them using a system of equations. So here's our two lines that we just found. So this is our system of equations. Now you've got options. You can solve the system however you want. Substitution, elimination. I'll go with substitution here. So I already have a variable solved, like isolated all by itself. Y is isolated. It equals negative x. So wherever I see y in this equation, I'm going to plug in negative x. So specifically right there. So I'm going to put in negative x equals x plus 4. And I'm going to solve this. I'll subtract x from both sides. Negative x minus x would be negative 2x equals 4. Divide both sides by negative 2, so x equals negative 2. All right, so there is my x value. Now we're solving the system, so I also need a y value because we're looking for their intersection point, which is a coordinate. So go ahead and take that x value and plug it back into one of your original equations. It doesn't matter which one. I'm going to put it in right here. So just think about it. If I plug negative 2 in right there, negative 2 plus 4 gives me positive 2. So y equals 2. Okay, so we could write that as a coordinate, which I think is what I have right here. Yes. So that would be the coordinate negative 2, 2. And let's locate that. Negative 2, up 2, boom, right there. And that's pretty much what we thought, right? So we now have the lines, not very straight, sorry. Perpendicular, we know that's at a right angle, and we know that's where they intersect. Now we just want to find the distance between these 2 points now, and that is going to be our fourth and final step. So it says find the distance between 1, 5, that's this point here, and negative 2, 2. Negative 2, 2, that's this one here. We want to find that distance, and how do we do that? How about that little thing called distance formula? Yeah. Let's go ahead and write that out. That is the square root of x2 minus x1 squared plus y2 minus y1 squared. Go ahead and substitute things in carefully there. So my x2 minus my x1, I could do negative 2 minus 1 squared plus I could do 2 minus 5 squared. Okay, let's go ahead and simplify. Negative 2 minus 1 is negative 3, and negative 3 squared gives me a positive 9. Plus, over here, 2 minus 5 is negative 3, and negative 3 squared also gives me a positive 9. So I end up with the square root of 18. And that's it. You did it. Final answer. Now, if you know how to simplify radicals, you can go ahead and simplify that further. If you pulled that out to the side,